Okay, I would like to officially welcome everyone again from our Defending Digital Privacy Network. Again, my name is Jum Supaporn Darak, a program consultant for Human Rights Lawyer Association, and I will be a moderator tonight. And I would like to thank you all for joining us. We have like 52 people registered from Philippines, 22 from Thailand, 8 from Indonesia, 20 from Malaysia, and also from the US, Canada, and India. So in all, we have 114 people who register in this session. Anyway, they might not be able to join tonight, but our Zoom record will be posted on our website later on. And yes, and we are glad to be part of this program to provide and facilitate knowledge to DDP network. And digital privacy is crucial for cultivating and sustaining democracy. We understand the important it is to defending digital privacy as a personal freedom in a digital connected world. So various entities, including government and corporations, closely monitor and analyze our online activities. Protecting our digital privacy is essential to maintain personal freedom and ensure that we can express our views and explore interests and communicate without undue security and censorship. And protecting our digital privacy can help us to mitigate the risk associated with the unwarranted surveillance. SLOA collaborate with the American Bar Association, Rule of Law Initiative, or ABA Rowley. We organize virtual seminar series to our network in Southeast Asia, like a short seminar, just 1 hour for us to be able to participate. So today is our third, and the fourth one will be in December 21st. Our speaker will be human rights lawyer Guntika Nutjalat. She will be talking about the state of privacy and data protection in Thailand. We will give you the example. If you would like to join, please see in the chat box. And we will share in the email as well later on. And for today, we will have 60 minutes, as same as we do in general. And we will do have Q&A.
Association sa mga abogado ba? Asa man ang association? Pro bono.
Right? Can you perhaps mute? Okay, thank you. And today we aim to do like 60-minute session, and we have 15 minutes for Q&A. If you have question, please write in the chat box, and Dr. Benjamin will answer your question. And I would like to give this floor to Riz from ABA Rowley to introduce Dr. Benjamin Fung to you all. Riz?
Good evening, everyone. I am Lizel Parahas from ABA Rowley, Philippines, a Senior Regional Program and Operations Manager. Thank you for carving out time tonight to join us for this important discussion. And we are honored and privileged that despite the time difference from the jurisdiction's time zones, where he will be with us to discuss on the topic of privacy preserving data publishing and data mining. Dr. Benjamin Fung is a Canada Research Chair in Data Mining for Cybersecurity, a full professor of School of Information Studies at McGill University, and an associate editor of IEEE's Transactions of Data Engineering and Elsevier, I hope I pronounced that right, Sustainable Cities and Society. He received a PhD degree in computing science from Simon Fraser University in 2007, collaborating closely with national defense, law enforcement, transportation, and healthcare sectors. He has published over 140 articles that span across the research forums of data mining, machine learning, privacy protection, and cybersecurity, with over 14,000 citations. His data mining works in crime investigation and authorship analysis have been reported by media, including New York Times, BBC, and CBC, and many more. Dr. Fung is a licensed professional engineer in software engineering. We will provide you with the URL of his research website so that you could see the many list of accomplishments of Dr. Ladies and gentlemen, please join me in welcoming Dr. Fung to this webinar. Good evening.
Yeah. Thank you. Thank you for the introductions. Before I start, I just want to make sure, can you see my screen now? Is it okay? Good. Okay. So thanks for the introductions. There's one more important title. I'm the father of two troublemakers. They are now 18 and 16 years old. So today I'm going to talk about two topics. Is data mining. I want to give you a general introductions on what data mining is. And then I will talk about privacy preserving data provisions and privacy preserving data mining. So I'm a technical guy. I'm not familiar with the laws and regulations, but I hope at the end of this session, you will learn something from the technical side. So I will do it in a very gentle way, without mathematical equations, without any complicated algorithm. Okay, but you will get a general idea what the capability of data mining can do. Okay. So data mining. So data mining, this is the textbook definition. It's a process of extracting interesting patterns or knowledge from huge volumes of data. Okay, when we say interesting patterns, it's a bit subjective. Okay, it can be interesting to you but not interesting to me. So what do we mean by interesting patterns? It's supposed to be non-trivial, implicit, and previously unknown and potentially useful. So we want to extract patterns from huge volumes of data. And we don't want to just extract the patterns. We want to do it in an efficient manner. We want to do it in an efficient and scalable manner. Efficient in here means we want to get it very fast. So if you submit the request, we want to give you the response within 1 second. This is efficiencies. Scalability means that, okay, we may be very efficient for 200 megabytes of data, but what if I give you 2 terabytes of data? Can I still give a response in 1 second? That's the scalability. Okay, and we want to make it practical. It means that we want to actually be able to use it in real life scenario. And the term data mining you may have heard about from different channels, different social media. I would say the term itself is actually wrong. It should not be called data mining, right? If you think about the process of gold mining or silver mining, you will find that, okay, what do we do in gold mining? We have a bunch of low-level materials like kind of stone. We extract the gold from there, right? So that's gold mining. What we are doing in here is that we have a bunch of data in there that has low-value data, and we want to extract the knowledge from the data, right? So a more logical term to call it should be knowledge mining instead of data mining. But anyway, so people like calling it data mining because of the marketing strategy purpose. So you will hear different terminology for data mining. You will see knowledge discovery or BI. They all refer to the same domain. And today, in the next 20 minutes, I would like to talk about 3 data mining functions. These are the major functions in data mining. So they are classification analysis, association, rule mining, and cluster analysis. So after 20 minutes, you should be familiar with these 3 terminologies. Okay. Okay, before we talk about data mining, let's put us in a big picture. Okay, so when you talk about data mining, machine learning, we have to think bigger than what we do just on social media. Okay, let's imagine we are the manager of a supermarket. So let's say we have some branch in different countries. We have one in Philippines, one in Thailand, one in Indonesia, one in India. So we have different database in different countries. Those are called the online database. The local database is mainly for the local transactions. So when a customer, let's say when they use their credit card and check out at the cashier in the supermarket, that transaction will be stored in the local database. Let's say a couple of months later, a couple of weeks later, they go back and do a refund, then that record will be retrieved from the database and then do a refund for the customer. So the local database is pretty much for the daily operations of the supermarket. But the database usually contains too much detailed information. It is not good for managers to make decisions, to make strategic planning. So usually if you want to do longer period planning, we would like to integrate the data together. We would like to clean the data and then integrate the data together into something called data warehouse that is like the aggregated information. The data warehouse is not a backup of the database. The data warehouse is a summarized information of the database. So for example, in order to do for the manager, they don't need to know exactly what is the telephone number of each customer. They don't need to know the exact postal code of each customer. They just need to know maybe the first 3 digits of the telephone number or the first 2 numbers of the postal code. Maybe that is already enough to perform the data mining task, right? This is also related to privacy. So in practice, right, in practical scenario, we actually do not need all the details in order to do the data mining task. And we will come back to this, okay? So data warehouse is the aggregated informations. In order to perform a data mining task, we don't need the entire data warehouse. We just need a small subset of the data warehouse. So we just select a task relevant subset from the data warehouse, and then we put it into data mining algorithm. We generate the knowledge and present the knowledge to the user. Okay. And then the user see the knowledge, they may not like it. This is not what they want. Then they will go back, right? They will go back to the previous step and then change the process. Okay, so that's why there's a loop to go back in here. Is it so far so good? Are you getting the knowledge? Okay, good. So this is the big picture, right? So data mining is one of the process in the enterprise information systems. So let's jump into the first data mining function I want to talk about. Okay, classification analysis. I would like to ask one of the, yeah, please mute yourself. Good. Okay, so classification and analysis. So let's say we are working in a bank, right? In a bank, we want to approve some loan or mortgage application, right? Loan applications. So of course we can do it manually, but nowadays we can also use data mining, machine learning methods to automatically determine whether we should approve a loan or not, right? So let's say we want to build such a system. And so let's say in the past history, we have 6 customers in here, right? 6 customers in here. So based on the past history, based on the job, based on the age, we determine whether we should approve the loan or not. So this is we call this is a class attribute. This is called the class attribute. So in order to do classification analysis, we must have at least one class attribute. That is the attribute that you want to make prediction in the future, right? So you want to predict whether I should approve a loan based on job and age. Okay, of course, this is a simplified data example, right? But in real life, it's much more complex. So in classification, we call this is called training data, right? So we know the true answer, the correct answer of each of the applicant. We know whether we already approve or disapprove that loan already. We call this training data and put it into a classification algorithm. You can treat this algorithm as a black box for now. We put it into this black box. This black box will return a classifier. So this classifier is like a summary of the training data. So we can use this classifier and make prediction on future cases. Let's say when a cook who is 37 years old come into our bank, we want to determine whether we want to approve or disapprove this application. And in many banks, they are already using this type of recommended systems internally. So for loan approval. So there are several processes, right? So what the first step in here is to put it into the algorithm and produce a classification model. So what's inside the model? The model inside, you can consider there are different types of model. One type of model is like a bunch of rules, right? So you can imagine there's a bunch of rules in there. The rule will be something like, if the job is a cook and his age is larger than 25 years old, then we will classify him into approved, right? So you can imagine there's maybe thousands of rules inside this classifier. That's one type of classifier. Okay, and in practice, we do not just want to learn the classifier and then use it right away. We don't just do it in this simple process. Okay, what we want to do is that we want to test the classifier. We want to test the accuracies of the classifier before using it. Okay, we don't know how reliable that classifier is, right? So we want to test how reliable it is before actually applying them to the unseen case. So how do we test the classifier? Okay, so this is how we do that. Suppose we have, let's say, 6 records in here, right? 6 records in here and 4 records in here. We have 10 records. In practice, it would be 10,000, but in here we have 10 records. And we know the true answer for all these 10 records, right? So we do not, even though if we have 10 records, we do not use all 10 records to train our classifier. We only use 2/3, let's say 60%, right, around 60%, to train our model. And then we reserve 1/3 of them to test our classifier. So how do we test it? We pretend, we basically cover up the true answer in here. We put these 4 records into the classifier and then ask the classifier to guess whether this should be yes or no, whether we should approve the loan or should not approve the loan. Right? So the classifier will make a predictions, right? Let's say the classifier will vote for yes in here, for the first one, that's correct. And the classifier will say this is no. The classifier make a mistake on the second record. And then the third one, the classifier vote for vote for no. And the fourth one, the classifier vote for yes. So in this case, 3 out of the 4 records are correct, right? Are correct. So in this case, our accuracy is 75%. So we can assume, okay, the accuracies of my classifier is 75%. Then when I apply it to the real life scenario, my expected accuracy will be 75%. Okay, so that's the idea of classification analysis. It has been widely used on many data mining tasks and machine learning tasks, including object recognitions, even on the Tesla autopilot driving, how they recognize object. Many of them are based on classification analysis. Okay. So classification analysis is not only used for credit card loan approval, it can be also used for fraud detections. For example, when you scan a Visa card or credit card transactions, they want to determine whether this is fraudulent or not. When you actually, this is doing it on the fly sometimes, right? When you scan your credit card at the cashier, sometimes it takes 2-3 seconds, right? Sometimes it's already going through this classification process to determine whether that transaction is fraudulent or not. Of course, it can be used for medical, for any domain. Okay. So the second function I want to talk about is called association rules mining. This is a second function, second data mining function. Okay. So again, imagine we are the manager of a supermarket, and we have every time when a customer check out from our cashier, we know exactly what that customer has bought, right? We know that, okay, in that transaction in there, that customer bought bread, butter, and diaper. Okay. So as a supermarket manager, we have maybe millions of transactions in our database containing all our past record. or a purchase record from the customer. So what we want to do in here is to maybe to increase the sales, of our supermarkets, right? So one way to increase the sales is that, okay, I want to identify what items are purchased together frequently. Then in theory, if I know that A and B are purchased frequently, then I can just put them closer to each other. Let's say bread and butter. I put bread and butter closer to each other in the supermarket on the rack. Then hopefully by doing this, I can increase the sales of both items, right? When you see the bread, you may grab the butter, right? Another way to increase the sales is that, okay, I know A and B and C are related. Okay, I can put A and B further apart. I put them further apart, and I force the customer to, when they want to buy A, they will be, I put the more expensive item between A and B. So I force the customer to look at C, because when you buy A, you need B. I force you to look at C, which is more expensive. So this is one way to also increase the revenue for the supermarkets, right? So, so in data mining, we have a way called association rule mining to automatically extract all these correlations, all these patterns from the database. The most famous, of course, you will know that bread and butter are related, but we don't need data mining to do that, right? We know that by common sense. We don't need to spend 2 hours on data mining to extract this common knowledge. But data mining can extract patterns like the hidden patterns. This is the part that most of the commercial world would be interested in, the hidden patterns. For example, one of the most famous example is diaper and beer. So data mining find that diaper and beer are actually related. I don't know whether this is the case in Asia, but in United States, there's a pattern between diaper and beer, especially in the evening. As a data mining guy, I cannot explain why diaper and beer are related, but some people propose a theory. The theory was something like, if the baby needs diaper in the evening, okay, the mom usually doesn't want to go out. The mom will ask her husband to go out. When the husband go out alone, he is more likely to grab the beer. That's a theory people propose to explain these correlations. But if you ask me, my explanation is much simpler. If you drink too much beer, then you have babies. Okay. Okay. Anyway, so we can use this association rule mining to extract all these hidden patterns. And I would like to emphasize that we are not extracting just one pattern. This is not the same as doing statistical analysis, right? In statistical analysis, you may think that, okay, diaper and beer may be related, then you do a statistical test. This is not the case. We will automatically extract all these patterns for the user within a couple minutes. And this technology can be used in many domains. One type is called the basket data analysis, the one that I just talked about. It can be used for cross marketing. Let's say when you buy life insurance, I will recommend you to buy the car insurance. Web log analysis. So before you click on the next web page, let's say when you are browsing a specific website, before you click on the next page, the data mining application can already predict what will be the next link that you will click. So they can push the web page to your browser before you actually click on it. This is called web log analysis and DNA sequence analysis. Okay, the third function I want to talk about is called the cluster analysis. This is also called unsupervised learning. So the purpose in here is very simple. I give you a bunch of objects. These objects can be patients, it can be customers, it can be passengers. Okay, I give you a bunch of objects, and the job in here is to group them by similarity. Okay, so we generally we want to group similar objects together into one cluster. the similar object should appear in different clusters. So that's the meaning of cluster analysis. Let's say if this is not people, if these are like books or articles, right? So we can group them by topics. And then after we group them, let's say this is about sports, this is about finance, this is a sport topic. Under sport topic, we may have soccer and hockey, and then under soccer, we have World Cup. So you can have a hierarchy. It's not just a flat clustering, it can be a hierarchy of cluster. And then after building this hierarchy, we can allow the user to browse into these objects in a logical manner. And we can do this automatically without human intervention. So the data mining, the clustering process itself can be a standalone process. It can mix and match with the previous function I just talked about, right? You can first cluster your customer or your patients into some group first, and then for each group, you can perform the pattern mining. You can extract the patterns from each group, and then so data mining system is like a mix and match of different functions. Okay, so I think I just give you a very quick introductions on what data mining is. So you know what company can do, what is the capability of companies can do with the data mining or / machine learning technologies. Now, given that, we would like to talk about how to do it in a privacy preserving manner. Okay, so there's a large domain called privacy enhancing technology, PETS, PETS. Let's put it into a scenario, let's say healthcare or transportations. When we talk about privacy protection, I always like to consider the life cycle of data. Consider when a company collect a piece of data, what will happen on that piece of data? That is called the life cycle of data. So let's say we look at the patient information to have a more concrete example, right? So the hospital may collect information from the patients. This is called the data collection, right? After they collect the data may be integrated, right? So you have different departments in the hospital, and sometimes hospital may need to share data across hospitals. So you need to integrate the data at a certain point in order to see the big picture of that patients. So after you integrate, you may need to share the data, right? For example, after you integrate data together, you may need to share the data to a third party, let's say for university to do research, or may need to share the data to pharmaceutical company to do research. So in some cases, there are legitimate reasons to share the information to a third party. This is called data sharing or data publishing, right? There are two terminology in here. After the recipient receives the shared data, they want to do data mining, right? They want to do cluster analysis, association rule mining, cluster classification analysis on top of the shared data. After they have the data mining, they want to share statistics to the public or to other people. This is called result sharing, or it can be sharing the classification model I just talked about 20 minutes ago. And then at the end, we would like to archive the data. At a certain point, in some cases, we may want to dispose the data. Okay, so that's the life cycle of data. So when we talk about PETs, or privacy enhancing technology or privacy preserving technologies, if you just stick the word privacy preserving before each of this life cycle, let's say privacy preserving data collection, or privacy preserving data sharing, privacy preserving data mining, you will find tons of articles, research articles from university, okay, from professors. So so when we talk about privacy, the first thing when you talk about privacy with other people, the first thing you need to consider is which phase are you talking about? Okay, not just thinking about privacy as a whole universe. You need to think about which step are you talking about. Okay, so for now, in the next maybe 20 minutes, I would only focusing on data sharing, because that's the most concerning one. So when one party, right, let's say transportation company, when they have to share data to another party, what is the privacy concern in there? Okay, so we want to talk about privacy preserving data publishing. This is a project I did in Hong Kong several years ago. So I'm a Hong Kong Canadian, so I did this project for Hong Kong several years ago. So Hong Kong, they have a Red Cross, and Red Cross in many countries is responsible to collect blood from the general public and distribute the blood to the hospitals, right? And then at the hospitals, the medical doctors are the one making decisions whether that patients need blood transfusions or not. But Red Cross would like to monitor how the hospital utilize their collected blood, because they spend so much effort to collect it. They want to maximize the utilizations. So periodically the hospital have to submit something called blood transfusions reports or blood transfusions data back to Red Cross, and Red Cross would like to do some data mining on top of the received data. So clearly there's a legitimate reason in here for Red Cross to receive that data. But you can imagine this blood transfusion data contains a lot of private information about individual patients, right? About why do they need that operations, all the medical information about that patients. So our job in there is to develop a software systems to anonymize this database into a version that can be used by Red Cross without privacy concern. So this is I would say this is the simplest scenario in privacy preserving data sharing. This is the following problem, right? So we have the blood transfusion database owned by the hospital. What we want to do is to develop an algorithm, a method, software, to anonymize it into another version, and we want to share this version to Red Cross. So we assume the recipient of this data can be both good guy, like the Red Cross manager, or a bad guy, right? So we cannot guarantee all the people in Red Cross are good people, or maybe they are good people, but they are careless good people, right? They may put the data on a USB drive and lose the and lost the USB drive, right? So we assume the recipient are both good guy and bad guy. Okay, so for this, that's why we want to make sure that for the shared data, it has to satisfy two requirements. The first requirement is that we want to prevent the bad guy from inferring sensitive information from it. And then we also want to make sure it is still useful for the data mining purpose for Red Cross, right? So we want to achieve both requirements. Let's say this is the data we want to release, okay? Of course, this is very simplified data. In real life, it's much more complex for medical information. So this is called the patient data, and we have the name of the patients, we have the job, sex, and weight of that patient, and then we have maybe some disease of that patient. We consider that disease is a sensitive information in here, for example. Okay, so the first job they do for nowadays, many companies, when they share your data to a third party, this is what they do. They remove before I do it, I should talk about the attributes. So there are three types of attributes. One type is called the explicit identifying information, like the name, your insurance number, your telephone number. Those are explicit identifying information. Another type of attribute is called the quasi-identifier. They are not unique identifiers, but the combination, okay, the combination can make a patient unique, right? So they are not dangerous individually, but the combination make it dangerous, because you can use it to identify a person. And the third type is the sensitive information. And nowadays, when the companies share your information to third party, what they do is that they will first remove the your explicit identifier information, and then they will release this quasi identifier information and the sensitive information to a third party, and they may assume this is privacy preserving. Okay, but I can tell you this is not safe at all. This is not secure at all, because it is possible that the attacker may have access to some some external information, If the attacker has access to some external information and try to link this information back to your release data, then we can link up the information. For example, we can link up, okay, Duck is a lawyer, male, 85 kilogram. So by using this, I can easily identify that, okay, a duck is has blood disease in here. By simple linking the outside information, I can kind of crack the patient information that you have. This type of attack is called the record linking. We are trying to link the record by the QID, by the quasi identifier information. Okay, then another type of attack is called the attribute linking. How to do attribute linking in here? Let's say in here, Emily is a dancer, female, 60 kilogram, and I use it to link it to this database. In here, we have 3 records who are dancer, female, 60 kilogram. So it looks like it's safe, right? I don't know exactly which record belongs to Emily, but in here, 2 out of the 3 records have skin disease. So I can make an inference that Emily has skin disease with 67% confidence, right? So even though I cannot exactly link which record belongs to Emily, I can still make inference on the disease that she has. Okay, so this is called the attribute linking. So how to prevent this type of linking? There are many ways to prevent this linking before we release the data. We can, for example, we can randomize the data. We can swap around the data swap the data, and then so that you can no longer link to individual patients. By doing this, we will screw up the correlation between different attributes. So the data may no longer be useful. Okay, although it prevents privacy, but the data will become useless in many cases if you do this approach. So what we do is that we would like to generalize the data. We want to generalize the data. For example, we want to generalize engineer and lawyer to professional, maybe musician and dancer to artist, and then professional and artist to any job. So we want to generalize the data. That's maybe a better approach. So one of the most commonly used privacy requirement is called the K-anonymity. So let's say this is the data we want to release, okay? And what we can do is that we can, again, generalize the data, right? We can generalize the data. We can generalize musician and dancer to artist. We can generalize engineer and lawyer to professional. And then we can generalize the weight to intervals of weight. So in general, what we want to do to protect the privacies of the patients, we want to generalize them into groups, into groups, right? Into groups such that each group is large enough. So what do we mean by large enough? We want to say each group contains at least K records. So this is called K-anonymity. K-anonymity meaning that we want to make sure that each group contains at least K patients. So even though someone is trying to link to that record, they will not be able to tell which one belongs to Duck, which one belongs to Emily. So this is called the K-anonymity requirement. And in addition to generalizing the data to a group, we also want to make sure the sensitive attribute in there has a good mix of different sensitive attributes. So even though there are 4 artists female, 60 kilogram in here, we want to make sure that there's a good mix of different disease in the same group. So that's what we mean by confidence bounding. I will skip some of the slides in here. And then we don't want to just do privacy protection. Remember, another requirement is data mining. We don't want to make the data useless. We want to still keep it useful. So what we want to do is to generalize the data very carefully. We don't want to just randomly generalize the data. We don't want to just randomly add some noise to the data, because if you add too much noise to the data, when you release the data to the recipient, when they try to generate, let's say, a classification model from the data, they will have a very low quality model. If you generalize the data too much, they will have a useless model, and then they can no longer use the model to make predictions in the future. So the accuracies of the predictions is indirectly related to the quality or how much noise you have add to the released data. If you add too much, then the data is no longer useful for data mining. Okay, so I'm not going to talk about the technical stuff, but what I want to illustrate is that by adding the noise to the data, we can have a very good privacy protections on the patients, and there's a price to pay. The price is the drop on the accuracies. Okay, so the data will be slightly less useful than the raw data. But what I want to illustrate, what I want to emphasize is that the price is very small. Maybe it's dropping the accuracies by 2 to 3%. By dropping 2 to 3% of accuracies, we can protect the privacies of individuals, of patients or passengers. Okay, so this is the message I want to deliver. Yes, there's a price to pay. There's a drop on the accuracies, but the price is very small. Okay, the scenario I just talked about was a simple scenario. It's just a single provider making a single release. In real life scenario is much more complicated because new patients keep coming into the hospitals, right? So, and then periodically the hospital has to make a release to Red Cross. So we need to make multiple release, right? So how can we make sure that even though if we make multiple release, it is still secure, it is still privacy preserving to release the information? So again, there are already tons of techniques, methods to achieve this complicated scenario. There are many other complicated scenarios of data integration, right? For example, there may be two hospitals or two financial institutions. Maybe one is a bank, one is a credit card company. They may want to integrate the data together in order to perform a better mortgage approval process. They want to build a classifier together. But they are competitor with each other too, right? So on one hand, they want to collaborate. On the other hand, they want to compete with each other. So we already have existing methods on how to do this complicated process, how to do the integrations without disclosing extra information to another party. We also look into different types of data, right? So it's not just database table, it can be very complex data. For example, many hospitals have already tried to use RFID, radio frequencies identifier. It's like a kind of like barcode, but it's more unique. So you can put a RFID on every object, on every patient, right? One of the most famous or commonly used example is on babies, right? On babies, they put an RFID tag on babies. That's because there was some cases around the world that when the nurse take the babies from the mom, take the newborn baby from the mom and take the babies to go to the shower, the nurse mix up the babies, right? All the babies look the same after they take off their clothes. So the nurse mix up the baby and deliver the baby to the wrong mom. And the mom, since that is a new mom, the new mom may not necessarily recognize their baby, and then the mom doesn't recognize that until 20 years later. So there was some medical faults or incident like this. So people now putting RFID on babies to make sure they won't mix up the babies. So, but once we start tagging babies or tagging patients, there's a privacy concern, right? In the database, you will see this, right? You will see that, okay, that patient number 100, we know that she is at time 1, she is at location A. At time 2, she is at location D. So again, this is a very unique information. We already have existing methods on how to anonymize trajectories so that we can still see the major traffic flow, but not able to pinpoint individual patients from the database. The same techniques can be applied on transportation sector, right? So when, let's say, transportation company, now I think it's very common to use the some smart card, right, for the transportation. That smart card on the database, it contains all your information, right? All your location information. It's called spatial temporal informations. So when the company need to share the data to another company for traffic analysis, they can also use they should also anonymize the data before they share the data. And this is the last technique I want to talk about. I just want to give you what is the capability that the privacy community can do nowadays from the technical side. This is like magic in here, okay? So again, the scenario is the same. The hospital want to share data to a university or to a data miner. So the problem in here is the same. Hospital share data to the data miner. But in practice, the hospital actually do not have the resources, do not have the human resources to handle all this data mining or research requests, right? The primary business of the hospital is to treat patients. It's not a data provider, right? I don't have a IT team to serve all the data mining requests. So what we can do is actually we can encrypt the data. We can put a password on the data. We encrypt the data, and put the encrypted data on the cloud. This is possible. We can put the encrypted data on the cloud and let the cloud to handle all the data mining requests from the data miner, okay? But the problem is that when you talk about cloud, we don't trust the cloud, right? The cloud is running by Google, running by maybe governments. We don't trust those entities, right? So that's why we want to encrypt the data. We want to put the password in there so that even the cloud cannot read the data. And magically, what we can do is that we want the cloud to do everything. We want the cloud to store our data. We want the cloud to receive questions, to receive query. We want the cloud to give the answer back to the data miner. We want the cloud to give a privacy preserving answer back to the user. But we don't want the cloud to know anything. So we want the cloud to do everything, but we don't want the cloud to know anything. Okay, this magic, it can be achieved. It's already doable in the privacy research community. Okay, so this is some of the major advancement that has been made in the privacy community in the last few years. Okay, so this is the last slide I want to show. Okay, so takeaway message. So I want to illustrate that there's a wide array of privacy preserving technologies already exist. They are already mature enough to be applied, to be deployed in many real world applications. But why don't we see them everywhere, right? Why don't we usually just see them in one or two companies. Let's say Apple, right? The Apple focus on privacy. This is one of the marketing strategy they use, right? It's because of the lack of motivation from the private sector, right? So the private sectors always see privacy technologies as a way to, it's one of the problems that will decrease the quality of their data. They are thinking in a binary mode. They're thinking about that, oh, the customer will share or not share that attribute to me, right? So let's say on Facebook, you can click, you share your marital status or not sharing your marital status, right? You will want to share your age or not sharing your age, right? Company always think about think about this in a binary way, share, not share. But we want to illustrate that it is not the case. It's not just share and not share. There's a way to generalize the data so that we can still protect privacies of the user. At the same time, the data mining company can still perform effectively on the collected data. Okay, so it's not just a zero-sum game. You can make use of the gray area for generalizations to achieve both tasks at the same time. And another point is that as a consumer, we may want to push the private company to do better privacies. Okay, privacy by design. So Apple is a very good example. So Apple successfully used privacy as a marketing scheme, right? So now they have an image in the general public that they are privacy preserving companies, and people kind of trust that they have the better privacy mechanism on their device, and that it becomes part of their marketing strategies. Another problem is the lack of motivation from the public sectors. In many governments, they do not, especially for some authoritarian government, they do not respect citizens' privacies, right? In Canada, I think Canada, US, maybe our governments, because of the citizens, they care about privacies. The government has to focus on this and then develop many new law like GDPR in Europe or Law 25 in Quebec. So, but some of the government around the world, they are not at the same level, right? So sometimes, let's say in the Chinese government, if you look into the law in the privacy, the data security law in China, I would say it is the most best written law in the world. But there's always one exceptional clause, right? Everything on the law is applicable to everyone in China except the government. So the government just is not bounded by those regulations. So that's a privacy, that's a concern in there. So I think that's all I want to share today. Finally, I would like to acknowledge the funding agencies of my research. They are NSERC, Canada Research Chair, and the National Defense, and my students are the real engine behind the scene. I'm just a user interface to present all these wonderful materials. Thank you very much. Thank you.
Well, thank you very much, Dr. Benjamin Fung. You give us such a very, I could say, it's like very systematic way for us who do not study technical terms to kind of understand. And I hope that the lawyer and attorney at law here understand as well. Yeah. And if you have questions, please write in the chat box, or if you would like to speak up, is totally fine, and to ask Dr. Benjamin.
Yep.
Okay, go ahead. From ABA Rolling, yes. Elizabeth, yes.
Yeah, thank you so much for such an interesting talk. And I did pay attention to all of it, but I wanted to go back to one of your earliest screens when you were talking about the entire process and referring to, I think it was the classifier as the black box.
Okay.
And,
yeah,
you know, this is a question that we as lawyers get quite a lot is, you know, these through data mining and machine learning, a lot of decisions are made, whether it's related to sentencing or potentially discriminatory practices in hiring, or, you know, as you were talking about loans, you know, this defense of, well, it's a black box, we don't know what the decision-making process is. But as we know in other processes, even in mathematics, you know, my daughter, when she's doing her homework for math, she has to show her process. She can't just show the answer. So, you know, is it necessarily having to be a black box, or is there a way to code this whole process so that you can see what the actual decision-making process entailed, so we can look at it and determine whether or not there was discrimination, or whether or not there was a corrupt practice, or whether or not there was a mistake? I think that's helpful for us as lawyers to start understanding. Thank you.
Yes, good question. So there are two types of classifier. One type is that, like this one, I can open up this black box to you and let you understand how the logic, what's the logic inside. I can even show you a tree, how we make a decision. This is called decision tree. Okay. So those classifiers are simpler. They can handle simpler data. Let's say for this case, loan approval is okay. We can use those simpler methods. But for more complicated scenario, let's say facial recognitions or object recognitions, or that is more fussy, right? So you can see that those applications are more fussy. So for those methods, for those applications, we cannot use this type of transparent classifier. We need to use more complicated, let's say deep learning, machine learning, AI methods, right? Those classifiers are black box, which means that even though if I open up to you, it's meaningless to you. It's a bunch of numbers. You would see just 2.35, 1.33. It's meaningless. It's for human. We cannot interpret those numbers. However, there's still a hope to do this, because the research community in the last few years, we are addressing this concern. So we are trying to develop something called explainable AI. So we want to still keep the accuracies of those complicated algorithm AI methods, but we want to able to explain to you how we derive that conclusion. So it is still not mature enough, but it is a very hot research area. Maybe in a couple more years, we will see a difference. Yeah, for those deep learning methods. Yeah.
Thank you. That's very helpful.
Yeah, welcome. Thank you.
Well, I think we have more questions from SLLA. Would you like to speak up, Nan?
Can you suggest solution on this scenario? There are cases where data is leaked to the public due to the reckless action of the hospital officer, and there are times that paper-based document of the patients are used to make paper bag for containing snack. And another time is when personal data is leaked from healthcare governmental application during the COVID-19 pandemic. And how can we protect ourselves or make an appeal regarding this issue at an international law level?
Okay. So again, we should go back to this life cycle, right? So when you say leak, it is possibly so when you say leak, maybe there's a reason, right? Maybe there's a legitimate reason why the health agency want to share data to a third party, maybe for COVID reason or for data sharing. So what they can do is that they can apply some of the techniques I just talked about. They can for example, for the statistics purpose, they can anonymize the data. One way to avoid this is to anonymize the data before they share it to WHO or to other organizations. So because for the higher organizations to a higher level up, they do not need to know individual patient information, right? So that's a perfect scenario to illustrate why we should do this process, right? Why we should generalize the data before we share them. So for the COVID example, that's the perfect case. We should generalize the data before they share this. Yeah, I don't know whether it answers your questions. And there may be sometimes it's also, we can also apply privacies on the sorry for swapping around. We can also apply privacy at the data collection step, right? So when we actually collect patient information from the patients or from individuals, we can already inject some noise into the data. This will make the data a little bit less accurate, but it preserves the privacy of individual patients. So we can do it at the earlier step too. So yeah, so that's the technical response to your questions. On the legal side, or on the social science side, that I don't know how to address that. Yeah.
Sorry, what type of noise would you inject at the collection stage? Because that's really important, I think, in terms of looking at privacy, like proactive privacy before you're having to deal with a breach.
Yeah, so we can mathematically calculate how much noise we can add. Let's say instead of disclose that I am 20 years old, I can disclose that I am now 23 years old, right? So that's the noise we can inject, right? So we can also make it more general. Instead of saying that a patient has certain disease, we can generalize the category of the disease, right? So and we can mathematically calculate in a way such that after we inject the noise, we can still perform good data mining on top of the collected data. I don't know whether this answered the questions or not.
I found it helpful. I don't know if anyone else has questions.
Yep. Yeah. So the message I want to deliver is that it is possible to still do data mining AI without compromise of the privacies in many scenarios. Not in every scenario, may not be in crime investigations, because in crime investigations, you need to exactly pinpoint that person, right? To do crime investigations. But in many other scenarios, say healthcare, social media, we can still do effective data mining without compromising privacies.
Well, are there any more questions from the audience? Now is 9 p.m. and is perhaps if you have one question. So if you don't have question, perhaps I would like to take this chance to kind of close our seminar because it's 1 hour already. And I would like to thank you very much, Dr. Benjamin Fung, for your time and your knowledge. And I hope that we can come back and see each other again if we need more something to learn from you, and we will keep in touch and get back to you. And thank you very much. And for the audience, for everyone, if you are interested in any topics, in anything related to data privacy, or if you would like to be a speaker, or you would like to introduce me or want me to reach out to someone, please let us know directly through HLLA. And again, thank you very much.
Okay, thank you. Thank you, everyone. Bye.
Yes. Bye-bye. Have a good day and have a good night. Thank you, Elizabeth.
Thank you. Thank you.